our first year of science operations, and that's when all the information about the gamma ray sky begins to flow out to the entire world. At the end of the first year of operations, the LAT team will release all the information about their individual gamma ray events to the world, and you can just find the information on the World Wide Web. So I hope that's given you a sense of why we're so excited about the mission. If you go to the last slide, you'll see our website, and we're just looking forward to a great launch. Thanks, George.
Thank you, Dr. Ritz. Our launch weather officer on Wednesday is Joel Tumbiolo from the 45th Weather Squadron, Department of the Air Force. And we'll go now to Joel for a look at our forecast for Wednesday. Joel?
Thank you, George, and good afternoon, everyone. Now that we have basically entered the month of June, not only is it the first month of our Atlantic hurricane season, no hurricanes out there, but it is also the beginning of our Florida summertime wet season, where we are basically dealing with daily afternoon showers and thunderstorms. The mechanism that generates all these daily storms is our East Coast sea breeze, and that is something we will be monitoring not only today, tomorrow, and Wednesday and Thursday, but basically the next 3 months. And it's this East Coast sea breeze that determines whether or not we'll have thunderstorms overhead, or if they'll be over Orlando, or whatever the case may be. If I could look at the satellite picture real quick, you could see basically a couple things we'll be looking at is there's an upper level low over South Florida that will enhance our thunderstorm activity today and tomorrow. Tomorrow we're looking at thunderstorms that will develop along this East Coast sea breeze and move back over the East Coast during the late afternoon and evening hours. So we will be monitoring that. The tower rollback, as Omar stated, will be around the midnight time frame tomorrow night. And by that time, any thunderstorm activity that is in the local area should have been dissipated and move off by that time. So we'll be set to go there. Once we get into launch day, we again will be monitoring this East Coast sea breeze and when it develops, how far inland or how quickly inland does it progress. One thing that we look at to determine those factors is the location of our semi-permanent high-pressure center that is located over the Western Atlantic. If that high-pressure center is north of the Cape area, the sea breeze will develop early, press inland, and all the weather will be well to our west and will be in good shape. If that high pressure is located to our south, that results in a later sea breeze development, and the sea breeze will be closer to the coast, so any clouds and storms that develop along it will be closer to the Cape area. On Wednesday morning, looks like that high pressure center will be pretty much at the same latitude as the Cape. So it's going to be difficult to tell exactly when that sea breeze is going to develop. Right now it will generate between the 11 o'clock and noon time frame. I realize our window's at 11:45, so very close to the beginning of the launch window is when this sea breeze will develop. And once the sea breeze develops, again, we'll be monitoring any clouds that develop along the sea breeze and how quickly those clouds grow. We have a rule stating that basically how tall the cloud is, we have to stay a certain amount of distance away from it. And that's one of the rules we'll be monitoring. As far as ground and upper level winds, I'm not expecting any concerns there. Upper level winds would be very light. The jet stream during this time of the year is well up in the northern tier of the U.S., so no concerns there. The ground winds will be light out of the west during the morning time frame. Then as soon as that sea breeze develops, they'll switch around to the east, but still be in the 10 to 15 knot range, well below the 25 knot ground wind constraint for launch. So we're not concerned with ground winds. Again, we're just going to be monitoring the clouds along the sea breeze and to see how tall these clouds are and see how far away they are from the launch pad. We'll use our weather radar and our weather aircraft to measure these clouds and get an exact location. So with that, we're basically just looking at a couple scattered layers of clouds, one at 3,000 feet and then another one at 25,000 feet. Again, the ground winds will be light out of the west in the morning, switching around to the east right around the beginning of the window, 10 to 15 knots. This time of year, the temperatures will be in the low 80s, and we're looking at a 40% chance of one of our weather rules being violated. And the main rule we're going to be looking at is what we call the cumulus cloud rule, which is a rule that states that depending on the cumulus cloud or the clouds that grow along the sea breeze, how tall the cloud is and how far away that cloud is from the launch pad. And we'll measure the exact distance and height of that cloud to determine if it violates one of those rules. So there's a 40% chance of that rule being violated, or any of our rules for that matter. It looks like the early part of the window will be more favorable than the end of the window. Once we get to the end of the window, we have more heating going on. That sea breeze has had a chance to develop even further, and clouds have a chance to develop even more. So the earlier in the launch window, the better in terms of the weather. If we were to go the next day, pretty much the same forecast, same scenario, and again, the beginning of the launch window is right around that time the sea breeze develops, so that'll pretty much be the story, not only for Wednesday, but Thursday and beyond as well, because again, the sea breeze is a factor that we look at pretty much from now until September. So overall, we're looking good. We'll monitor storms tomorrow, late tomorrow and tomorrow evening, to ensure they're gone before the time the towers roll back. And then once we get into the terminal count, we'll just monitor the sea breeze and any clouds that develop along it. So looking good. Thank you.
All right, thank you, Joel. And we're ready now to take questions. Please give your name and affiliation when the microphone comes to you. And we'll start here in the front with Marcia.
Marcia Dunn, Associated Press, I think for Dr. Ritz. How is this, why is this so much better than the Gamma Ray Observatory? And has there been anything since the Compton Observatory that has picked up the slack in Gamma Ray, represented by any countries that are out there?
Thanks for the question. The great leap in capabilities is several things together. The insights of various people who made GLAST possible, combined with just basic advances in particle physics detection capabilities. For example, there was a large amount of work invested in developing detectors for the superconducting super collider, which is a project that in the end didn't go forward in the United States. But those detector advances, those developments, are very much used on GLAST. So GLAST inherits from those advances in capabilities. So I think it's pure advances in capabilities plus the fact that there's been all this great experience from the previous missions about what works and what doesn't work. And therefore, again, it's the combined braiding together of these teams of people who have done astrophysics and particle physics in the past that have made these things a reality. Now, since the Compton Gamma Ray Observatory, in fact, there's been a launch of a very interesting experiment observatory called Agile. It's primarily an Italian mission, and it's operating right now, uses several of the same technologies that GLAST will be using. It's a much smaller observatory and has capabilities that are somewhere in between, closer to egrets, between egret and GLAST. And there's so much to do in the gamma ray sky. There are interesting things happening all over the place that having as much coverage as possible is absolutely welcome and great. And in fact, we have shared collaboration members between the Agile team and the GLAST lab team. So they're up operating right now, and we're looking forward to joining them in just a few days.
Thank you. And I'm not sure for who, maybe for Mr. Baez, what's driving this launch window? Why 11:45 in the morning if it's especially such a bad weather time? And if it goes to Saturday, I'm assuming you cannot launch on a shuttle landing day?
Yeah. Marcia, the 11:45 time is driven purely by orbital mechanics here, nothing else. We don't usually make our windows around the weather pattern. In fact, this window was established long before the summertime period. And we probably would have a constraint on Saturday with the shuttle landing.